Hey everybody, this is Larry. This is day four. Yeah, day four of the January LeetCode Day Challenge. Hope everyone's having a good year. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Today we have 2870, minimum number of operations to make array empty. And just, I don't know, just a meta comment. Where's my mic doing? 2870 means that it's a recent contest, so I probably maybe even remember it. I don't actually remember it though, so we'll see. You're given a zero-indexed array, nums consisting of positive integers. The two types of operations that you can apply on an array any number of times. Two elements that are equal and delete them from the array. Three elements from equal and negative one if it's not possible. Okay. So there are a couple of ways you can think about doing this. I think that one of them that I would say is that it relies on the fact that maybe I said it awkwardly. It relies on experience, right? And I don't know, it's just very awkward to be frank when I say it like that. And what I mean though is just that the core part of this idea, to be frank, I've done this a couple of times. Before today, obviously, because I've done this problem. But even when I first saw this problem during the contest, I think, because I think, I don't remember when the last time I did this, but I've done this like a couple of years ago. And so like the same idea. And the idea is kind of try to figure out, try to figure out how to go attack this problem. And to be honest, one of these problems is just, and which is why experience is important, is just playing around with the problem and ideas and stuff like this, right? Like you have to be able to play around. This is a problem-solving problem. This is not like there's no like, oh, just use this technique XYZ and then just do that and this and that'll be okay. I mean, maybe some people's explanation and videos or whatever, and you feel free to watch them. You may get that answer. But it's not that magical. It's just about playing with the ideas and playing with properties and trying to figure out, okay, what is true about this problem, and then figuring out, build the basis and, and come up with the solution that way. And sometimes you're going to be wrong, but that's okay. That's part of the experimentation and that's part of learning. And that's what I also mean by this experience, right? Is that if you've done it before, or it doesn't mean that you have to have done this exact problem before, but if you have done similar things before, then you would have an idea on like maybe a direction or basis to work on, right? This is a long kind of, I don't know if you count this as an intro, but it is just the way it is. And I think we talk, I think someone in my Discord saw asking about ad hoc problems, and that's basically what ad hoc problems are, right? I mean, it is focused on the, less on algorithms, less on data structures, this one particularly, but some other ones as well, but just about like, try to figure out what you can do and what you can't do, right? Okay, so let's play around together. N is pretty big, is it? I don't know if it is. Okay, N is 10 to the 5th, so you can't do anything like, you can't do anything like brute force, like, let's try to remove 2, do a recursion, we'll try to remove 2, do a recursion, and then we try to remove 3, dot, dot, dot. And of course, if you do it that way, you can kind of very quickly come up with a dynamic programming solution. So maybe I'm a little bit wrong on what I said. But I mean, you could do it with dynamic programming, but there is probably something similar, right? Actually, I don't know if, to be honest, I guess maybe now that I think about it, if I have a dynamic programming solution, maybe that's what I would, and I didn't want to prove, maybe that's what I would do. And the dynamic program solution, I'll just give it a quick pseudocode, is that, okay, so def, so we just write is like can be true. That's terrible naming, but what's it called? Can make empty. Okay, fine. Maybe something like this, right? And then you have, for this one, maybe you can make some easy optimization. One of the obvious optimization is that it doesn't really matter what the number is, right? Meaning that it doesn't matter if you're removing a 3 or 2, right? You just have to remove 2 pairs of 3 or 4s. So then maybe you could say it is of some n, right? And then now, yeah, if n is equal to 0, we return true. So this is kind of the basis. And then now we can make empty and minus 2 or empty and minus 3. And of course, you can memorize this and cache this and all this stuff. I guess this is actually a pretty good way of doing it as well. I mean, this is going to be O of n in the worst case, and as I said, you can memorize. There are some nuances, and you can very easily do what I was going to do next, right? I mean, like I said, memorize this, and this is just linear time, linear space, and pretty straightforward. Oh wait, I think I need more base case, but you get the point, right? Like if n is less than 0, return false, right? And then you could kind of play around the idea, and then now, actually, to be honest, I had this idea in my head when I first read this problem, but now that I think about it a little bit more, especially with what we just did, I guess I was trying to do bottoms-up dynamic programming without really without that construct, right? I mean, yeah, it's the same idea, or you do the same thing doesn't mean that it's the same visualization. So you can use the visualization that is the most useful to you. But I did this without the framework of dynamic programming, but I was just thinking, okay, well, 0, let's say it's true, then now, let me just write this another way maybe. Right, 0 is true, 1 is going to be false because 1 you cannot go anywhere. And then 2 is obviously true, 3 is obviously true, 4 is true because 4 could get to 2, right? 5 is true because 5 can get to 3 or 2, I mean, you only need one of these, really. And then 6 is true. And then really, you kind of see the pattern very quickly, right? Especially, even numbers, you can always just do it. I mean, just a little lazy. And then odd numbers, you can also get to the even number, which is true. So basically now, if you kind of think about it that way, even though, and yeah, maybe you could call this dynamic programming bottoms up, but the way I thought about it was basically, yeah, like think about the parity and stuff like that. So basically the only case that it is false is if one of the numbers appear once, right? So that's really the core idea. But this is what I mean by experience is that, now you're able to kind of jump to this kind of very quickly. You're going to be like, oh, I'm not going to do dynamic programming. All I need is a frequency table, right? So frequency table, at least in, it's going to look like this in Python. You can actually also just, I'll write it out. Sometimes I get comments about like, Larry, why do you write like your code in a certain way in these videos? I'm not going to lie. The way that I write these is just, a lot of the times it's for learning, especially on the daily videos. On the contest videos, I am trying to, do well in the contest and I do it quick, etc. But for the daily videos, very often I write it in a way that is for learning and for visuals, for clarity. So yeah, for example, you could do something like this, and this is, the same idea, right? Now you have a frequency table, and then now it's just for f.values, or for v in f.values. If v is equal to 1, we return false. Otherwise, we return true. And of course, you can obviously write this in a one-liner if you really like, especially in Python. But yeah, I am really wrong. Did I miss something? Oh, the minimum number of operations. Sorry. I didn't misread. I just forgot it. Okay. Then we have to kind of change a little bit. Okay. Whoops. I did actually remember. But, this allows us to do -1. If this is equal to 1, we return -1, right? And then now we have a total is equal to 0. We do some counting and we return total. And here, maybe we'll go back to the dynamic programming solution, quote unquote. So 0 is going to be 0. We don't need any operation. 1 is going to be -1. 2, we have one operation. 3, we have one operation because 3 goes to 0. 4, what would you do? You would go to 2 and then 0. So this is going to be 2. 5 is going to be min of, and I don't want to write the dynamic programming one again. Of course, in this case, you just do min of those two and have one of them be infinity if, if you cannot reach it. But yeah, 5 is also 2 because you can go to 3 or 2, right? So this is going to be 2. And then 6, you're going to obviously go to 3. So that's pretty much the idea, right? And then 7, you can really only go to these two. And so So this is going to be 3 dot dot dot, and you can very easily see that this is just going to be the ceiling of in this case v over 3, right? Because it's, and by saying v over 3, I guess it is what I mean. I don't know, right? And then you could write that as something like this. I guess technically like this, right? And of course, this is going to be, I know that there's some decimal stuff, so I'm just want to kind of do it for visualization. But the way that I would write it in thing with ceil is just going to be v plus 2 over 3, right? So that this keeps it an integer. To see why this works, just try for every number, I guess. That's the idea. 1374 days. And yeah, what is the time here, right? As we see, this is going to be linear time, linear space. And yeah, that's pretty much it. What did I do last time anyway? I guess it is the same thing, really. So I did C of K. Okay. But yeah, that's pretty much it. I wanted to, yeah, it's a new year, especially today anyway. I have a little bit more time, so I wanted to go in a little bit more detail than, and just kind of walk people through it, especially if they're beginners. Definitely let me know if you have a question or many questions. That's all I have for today, though. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.